This is a coral reef. Along with tropical rainforests, these are the most biologically diverse ecosystems on Earth. The large, colourful structures that you see before you are coral communities. Thousands of tiny coral polyps live on the surface of these structures. When they die, the carbonate skeleton they build around themselves remains, ready for the next generation of polyps to come and attach to. The corals gradually expand with the passing of each generation. These ones are likely to have taken centuries to get to what they are today. Despite being animals, coral polyps feed mostly on sunlight, thanks to the zooxanthellae algae symbiotically held within their jelly-like bodies. It is these algae that gives the corals their colour. The rest of the ecosystem revolves almost entirely around coral. The enormous coral structures, varied in shape, provide habitat for animals like fishes, crustaceans, mollusks, and sponges. This attracts predators who patrol the reef looking for an easy meal. Competition for resources such as food, space, and sunlight is intense in such a densely packed environment, and is the reason why coral reef ecosystems are so extraordinarily diverse.
Coral reefs not only contain the most diverse ecosystems on the planet, but they're also involved in everything from water filtration to shoreline protection. They protect coastlines from storms, help with nutrient recycling, maintain balanced relationships between organisms competing for the same resources, and support the local economies through the tourism and fishing industry. The Great Barrier Reef alone generates more than $1.5 billion every year for the Australian economy. Studying the coral reefs is also crucial for providing an accurate record of climatic events over hundreds of thousands of years, which includes recent storms and effects of human-induced climate change that can be recorded by the changes in growth patterns of the coral. It's important to keep this ecosystem healthy since the extinction of species reduces the biodiversity and it leads to a collapse in the ecosystem health and function. Since we don't know everything about all the species in the Great Barrier Reef, a keystone species could become extinct and we wouldn't realize the impact until they were gone. We need to develop a strategy to protect the reef for the health, management, and conservation of biodiversity, and to maintain the steady influx of tourism this ecosystem brings to Australia.
A current major threat to coral life on reef ecosystems is the crown-of-thorns starfish. It is native to reef systems in Indonesia and usually preys on large coral polyps. It is one of the largest starfish in the world, up to 25 to 35 centimeters in diameter. It feeds by wrapping around the coral colony and extruding its stomach onto it, digesting the soft tissues and leaving the bare skeleton. It plays an important role in healthy ecosystems as it normally consumes faster growing colonies, allowing the slower species room to grow. However, on the Great Barrier Reef, where it is an introduced species, it is responsible for 25% of coral degradation in the last 30 years. While species of pufferfish and triggerfish have been observed feeding on the crown-of-thorns starfish, it has no major predators in the wild. Therefore, except for human culling efforts, the pest has largely gone unhindered, with 3 major outbreaks in the last 40 years.
But all is not lost!
Our solution to this threat is to create an AI robot that controls the reef and uses a long syringe to inject the starfish with a transmissible neurotrophic agent which modifies the behavior of the starfish, in a similar way to the rabies virus or the zombie ant fungus. This compels the infected starfish to search out other crown-of-thorns starfish and kill them. The infected starfish will also die in a couple of days. This method should primarily be used during major outbreaks to keep crown-of-thorns starfish at a stable and healthy level.